Here we're talking about energy. We're talking a little bit about what we mean by energy. Everybody has some sense of what we mean by this value of energy. Moving objects have a certain amount of energy. Energy is associated with heat and with electricity. Living organisms need energy through the intake of food. And engineers and scientists harness energy to do many useful things. We generally consider that the law of conservation of energy to be one of the most important laws of nature. What we've looked at thus far for Newton's laws, which allow us to look at the forces acting on an object and thus predict its position and motion in the future based on the forces that are acting on it. While that can be very useful in many situations, it's also very limited in how difficult it can be to do those calculations. When we look at energy instead, we're able to simplify our calculations greatly, which give us a much better understanding of many systems without getting lost in the weeds of Newton's laws. One type of energy that we'll see is kinetic energy. Kinetic means moving or in motion, and indeed kinetic energy is the energy of motion. It takes a certain amount of energy to get an object to move, and the kinetic energy that an object like this rocket carries is a measurement of how much energy went into getting that rocket to move, and then how much energy would be released if that rocket were brought back to a halt. All moving objects carry kinetic energy. Kinetic energy depends on the size of the object, the mass of the object, and its speed, and so more massive and faster objects have a greater kinetic energy. Another common type of energy is gravitational potential energy. Gravitational potential energy is associated with an object's vertical position, its height above the ground. The potential part of potential energy here is the potential for gravity to do work on the object. That if you have an object that is high up in the air, if you let go of it, gravity will pull it back down, and you have a chance to release that energy. Having an object high up in the air gives you this potential to release that energy. We see that in things like water wheels, where you have water that's flowing down a hill. As the water flows by the water wheel, it pushes the wheel, and we're able to harness that to do work. Similarly, as we see in the picture, a roller coaster also uses gravitational potential energy. The roller coaster is brought up to the very highest point. There you have a large potential energy, and as the roller coaster slides down the other side, you lose that height, but that energy is released. Spring potential energy is energy that is stored in the compression or the stretching of a spring. A spring wishes to be at its natural length. We see here a few springs that are at their natural length. If we try to compress a spring with an applied force, that spring will resist by giving a spring force that pushes outward to resist that compressing force. If we pull outward on a spring, the spring will pull back in towards the middle and try to hold its natural shape. In either case, it requires an outside effort to compress or stretch a spring, and that outside effort is stored as spring potential energy. The final type of energy that we'll see commonly is thermal energy, which is the internal energy of an object. Macroscopically speaking, when we're looking at a large object, large by molecular standards, not necessarily large by our standards, this thermal energy is manifested as heat. And so a hot object has internal thermal energy more so than a cold object does. At a molecular level, we can treat an object as a series of nuclei, atomic nuclei, that are connected by springs. These springs represent the molecular bonds between neighboring atomic nuclei. And what happens is that on a microscopic level, these nuclei are oscillating, they're shaking in all directions, and so they carry, each one carries a tiny amount of kinetic energy. While the kinetic energy of any one nucleus is negligible, when we have a whole lot of nuclei, we have a real amount of kinetic energies from those individual atoms. Also, as our nuclei oscillate rapidly, they're putting pressure on these springs, which represent the molecular bonds. There's a certain desired length of the molecular bond, and as the atoms get closer or stretch farther, they take energy, put energy into or take it out of those bonds. And so that is included as well. These potential energies from the bonds are included in the total thermal energy of a system.